You all have asked, and I like to think that I listen and take your suggestions and run with them. And I feel like this one is long overdue. So, this is my first impressions video for Odin. Okay, let's get started. So, I've got a couple things up already. I've read through some of the documentation. The Odin documentation is interesting. There's not as much here as I had hoped for. But this is their homepage. If you haven't seen it, Odin's a data-oriented language for scene software development. It tends to fall into the C alternative collection of languages. It's programming done right by their take on it. It's so subjective, but from what I've seen, it looks nice. It's a general-purpose programming language with distinct typing built for high-performance, modern systems and data-oriented programming. Oh yeah, Odin is the C alternative for the joy of programming. So there's some docs, full demo, some examples. This is kind of neat. They've got like a little drop-down slider here. You can barely see that due to a color scheme, but this is indeed a drop-down, so you can see they've got like a little hello calculator type thing going on here, some array programming. I'd recommend looking through these if you have the time and the interest. They're pretty neat, and we're not going to be able to get into all of them with our project, which I'll talk about in just a minute. The context system's pretty neat. If you know much about Odin, you've probably heard people talk about the context system, maybe used it, maybe not. And then also there's some reflection type stuff that they have here as examples. They have a Discord. Feel like I should call that out in case people are interested and you want to learn more. You can join the Discord. Also, they have their principles listed right here. So simplicity, high performance, modern systems, and joy of programming. I think those are pretty great principles to guide development of a language. So there's Odin in production. Jenga FX are the creators of 3D animation software Embergen, GeoGen, LiquidGen, which are all fully written in Odin. The creator of the language, Odin, works for Jenga FX, so worth mentioning that. This stuff is actually really cool. If you're interested in like simulator type experiences with earth, water, flames, any of that stuff, it is really neat. They also have this really powerful list of companies, including some that I am very familiar with, like Bungie, Bandai Namco, Blizzard, Meta, Warner Brothers, Paradox. They make great games. PUBG, Rare. Wonder what Rare used from them. Probably LiquidGen, I have to imagine, for Sea of Thieves. But yeah, a pretty strong list of companies using products by Jenga FX who are also using Odin, because all of these simulators are written fully in Odin. The Chi-Aha Digital Twin Toolkit is written in Odin and can help answer your factory flow questions. I don't really know much about that comparatively, but that's another Odin product. I think it's nice seeing some of the things that are built with these languages. It helps add some credibility to them, which is nice. It's nice to see people building real things and showcasing real projects with the languages. Like Zig does this sort of with Tiger Beetle and Bun and things of that nature. Batteries included. It comes with high quality packages out of the box in its core library. I just realized this is probably kind of small. My apologies. I'm really bad about that, but this should be a little easier to see. So this is kind of neat. There's official libraries for major graphics APIs such as OpenGL, Vulkan, Direct 3D11, Direct 3D12, Metal, WGPU, WebGL 1 and 2, SDL, GLFW, Raylib, MicroUI, and Mini Audio have popular library bindings as well. Sorry, officially maintained bindings, I should say. So this is neat, right? Like it's clearly positioning itself as a language for games, for graphics, that type of stuff. And I think that's honestly a pretty good spot to try to position itself. Odin's open source, so you can check out the language source yourself and make contributions, all of that fun stuff. But yeah, let's actually talk about building something in Odin. Their docs are interesting. There's not a ton, but there is quite a bit, if that makes sense. I've scanned through some of these, like the overview, and you can kind of dig into this. You can kind of treat it as like a really thought out guide, but in terms of like specific docs, I don't know if you're necessarily going to find what you're looking for. This right here, though, this demo file is like, this is going to be the bee's knees for us. So what we're going to do is we're going to leverage this demo file, which shows as much of Odin as possible in a single file, including numerous examples of concepts, features, of the programming language. So all sorts of stuff here, including like, I believe these are compiler annotations, maybe might be the appropriate term for it, like the vet flag here, feature compiler flag for dynamic literals, package, import, all sorts of fun stuff, multi-line comments, information on how to get started, basics. So there's a procedure that's being built here, all sorts of fun stuff. So we'll refer to this quite a bit as we get going, because I know roughly what I need, but I don't know the syntax for everything. And I guess we should probably talk about what we're going to build. So I want to build a tool for inspecting ELF files. That's really it. It's not anything complex, but if you were to take this problem and say, how do I want to build this? You might come up with some pretty interesting ideas. And one of the things that I'm really excited about with this is that I think this will give me a lot of opportunity to play around with some of the things that make Odin interesting to me. Although I don't think we'll have much opportunity to really get into like the context system and, for lack of a better term, monkey patching libraries via the context. And that is really actually not the appropriate term, because the idea there with the context system is that it's somewhat limited in what is available to it, and it wouldn't really be monkey patching. But being able to control allocations and things of that nature through the context system is unfortunately something that I just don't think we're going to get into. Mostly because I will write all this code and I'm not pulling in any libraries that have assumptions on how things should be done. One last thing, if my voice sounds a little off, I am recovering from maybe the flu. I'm not entirely sure, but I've been pretty sick for the past week, and I am excited to get back to exploring languages. So pardon my voice sounding a little off, but let's get into it. Okay, I've got my projects folder here. We're going to make a directory called elf inspect, and then I'm going to cd into elf inspect. Now that we're here, it's completely empty. Probably the first thing I should do is look at this getting started page. And I have Odin installed via the Arch user registry repository. I don't remember exactly which, but if you want to follow along, you can install it through the install instructions here. One thing I found interesting is that I tried to use Mies to install it, and I did not have any luck. It looks like the ASDF installer backend that Mies is using maybe hasn't been maintained in a while. So if you're trying to use Mies, you might want to look at other options too. I ended up installing this from the AUR, but use whatever is appropriate for your system. If you're on Mac, Homebrew, and if you're on Windows, Scoop, or whatever Windows devs use. I truly do not know. Okay, so with that in mind, we have some stuff going on here. Example, like a hello program, essentially your hello world, Odin run. One of the things I'm curious about, is there like an Odin init? Okay, so if I run Odin, I've got build, run, bundle, check, strip, semicolon, test, doc, version, report, and root. So no init. Okay, that's totally fine. We're just going to jump straight into it. So I'm going to go ahead and vim, and this is going to sound weird, but I kind of want to think about the interface for this. So I think I'm just going to go ahead and code out main.odin. And I know roughly what I want this to look like. So I know that we need a package. It's going to be called package main. We're going to have some imports. I don't know which ones we need. I think we're going to need some core packages. So yeah, we'll go ahead and import core fumped. And then I think there's another one that I was looking at, OS for files. So if we wanted to look into that, we could open up the Odin packages page, make this a little bigger for you, and we could take a look at the core library collection. So the one I think I need is called OS, and I just want to verify that because I did a little bit of digging into this earlier just to kind of see what options were available. Yeah, cross-platform OS interactions like file I/O. Yep, so we can go ahead and pull this in as well because we're going to use this to read a file. I'm pretty sure there's an example of that in here. Procedures. Read entire file from file name. We're also going to need args because we're going to pass in the elf file. So you'll be able to call this binary and then pass in some x86 based binary that's been compiled. And that's what we will inspect. Okay, so we know we need core fumpt, we need core OS to get args at least, and then also some file reading. We have our main procedure, which I believe that's the correct syntax for. Just going to hop back over. Yeah, so we've got the basics, and then it's a procedure. Our main procedure, I'm pretty sure, is just the one that gets executed by our program. And they've got an example here of looking at args length like this. So we'll probably do something really similar. We can do if the length of os.args is less than 2, not less than or equal to 2. Fumpt print, I think we have print line. You'll notice I don't have an LSP or anything going on to help with autocomplete. So I will probably be tabbing back and forth a lot. I might cut some of that just because that might be annoying. But yeah, the idea here is, I guess one of the takeaways is that I really like languages that ship with really robust tool chains. It's not like I would make an exception for something really great, but I do feel like in 2026, it is really reasonable to expect a language to ship with an embedded toolchain. I think Go did this really well. Rust did this really well. And I think so many other languages saw them doing this really well. And they said, maybe we should do that too. So, I know Odin's pretty early in development. In fact, I actually don't even know what the current version is. Official releases, latest release. Dev 2026-01. So do they have like semantic version releases? I have no idea. It does not look like it. So yeah, I don't even necessarily know how to qualify how like production ready this is. Again, like Jenga FX has built some pretty cool things in it. There's some other things that have been built with Odin. There's games that have been built with Odin as well. So you can build stuff with it, but like how stable the standard library is, or like the language itself, I don't really know. Okay, so something like this, right? We want people to be able to call elf inspect and then pass in a binary. If you don't give me the args I need, we're just going to tell you that's how you use it. And then I just want to go ahead and do an early return. We don't need semicolons. It's going to be really hard for me to not remember to type, or to remember to not type. But yeah, syntactically, we can do variable assignments very similarly to Go here. So I can do something like this to get my OS args. And then if I wanted to, I essentially want to like read a file from that OS arg and load it into memory, right? So I've got data, and then we have multiple returns in Odin. So I can do something like data, okay, and then do read file path, something like that, no semicolon. And then similarly to Go, I like this a lot about the language. It feels very similar to Go in many senses, I should say. But we can say, if not okay, then return. So for whatever reason, we can't read that file, go ahead and return. Maybe we want to do like a fumpt print line here as well and say, cannot locate file. Cannot locate file. Something like that. I probably won't get too crazy with the error handling since this is a one-off project and not something that we're necessarily making production ready, but yeah. Okay, so once I've located that file and I've read it into memory, I want to parse it, right? So I'm going to do something pretty similar here. We're going to get the header, which I'm going to shorten to HDR. We are going to check if it's okay. So again, this procedure that we're going to write is going to return the header and whether the header was okay or not. And this will be a package that we write. So I'm just going to call it elf. We'll put it in some elf Odin file. And we'll say parse elf header And then we want to give this some data. Again, very similar pattern. If not header okay, let's just go ahead and return. I'm also going to just go ahead and print the header. And we'll add a function or a procedure, sorry, to print the header. And then I want our program headers as well. So I'm just going to call these PHDRs. PHDRS, okay. Same thing here. We're going to call parse program headers. And this stuff doesn't exist yet. We're going to have to write this, and that'll be the fun part. But I think seeing how the main Odin file is expected to interact with this might be helpful up front, which is why we're just kind of, I don't want to say pseudocoding, because I think this is actually be pretty close to what we need. But, you know, we can come back and change it as well if we need to. And then again, we'll do something like if the program headers are not okay, just go ahead and return. And then we'll call print program headers. And this will be PHDRS. Finally, I want to find the interpreter. If there was an interpreter, I'm going to call it interp and has interp. And again, we're going to depend on this ELF module that we haven't written yet. Find interpreter data and PHDRS for our program headers. If it has an interpreter, elf.print interpreter, interp, no semicolon. So yeah, this is the idea, right? So we have our main method, or our main file, I should say, is 38 lines. I feel like if you have watched videos on this channel, this should be very legible. Just not to toot my own horn, but I feel like the people that watch my videos are fairly advanced programmers. Not that I'm covering fairly advanced topics, but a lot of the things I'm interested in tend to draw a fairly advanced programmer crowd. And looking at this, you should probably be able to read this pretty cleanly, regardless of your experience with Odin or Go, or anything that is similar. Like it's a clean language too, I guess is what I'm getting at. But I would ask if there are any questions, but this isn't a live stream. This is a recorded video, so we're just going to jump into the next part. Before we do that, we know that we have an ELF module. I'm just going to go ahead and import it here before we forget. So I don't have this yet. It doesn't exist. We're going to have to make this. So we're going to make a folder. I'm just going to go ahead and write this. We'll hop back over to our actual terminal here, and I'm going to make a folder called ELF. And then I'm also going to, if I can type correctly, touch elf/elf.odin. We're going to go ahead and open that. And I need to give this a package. So this package is going to be ELF because it's in our ELF folder. I don't know if that's like a tight constraint that Odin has or not. It might be something that would be good to figure out at some point. But yeah, not too sure. We're going to get into some stuff that is a little different here. So what I'm going to do is we're going to start creating constants. And I don't know off the top of my head what the syntax for that is. So we're going to go to our demo file and try to find out. Constant declarations. Constants are entities, symbols, which have an assigned value. Okay, so it's this double colons. So no const keyword, nothing like that. It's just the variable and then, or the constant name rather, and then the constant value on the right of these colons. I will spoil this for you. I do have a little bit of a cheat sheet. I do not have all of the ELF stuff memorized. So I know that like the class constant is going to be 4 in our case. And these are essentially just indices. So I'm going to call it ELF indices class, and it'll be 4. ELF indices data will be 5. ELF class 32. So if it's a 32, it'll be a 1. If it's for 64-bit, it'll be a 2. this is probably, actually, I do think this is probably an interesting part, but it's not necessarily Odin specific. And I'm probably not comfortable enough with Elf to talk too much about like how Elf fits together. So bear with me as we get through this part. Once we have all the constants out, everything should kind of fall into place, and it should be something that is pretty easy to follow, even if you don't have much familiarity with Elf. So we have an LSB encoding constant. We have an ELF data to MSB constant. We have our file types. So if we have an ELF type of none, it'll be 0. If we have let's see, we've got our rel, which will be a 1. We've got exec, which will be a 2. Dynamic, which will be a 3, and then core, which will be a 4. You know, it's just worth mentioning, like, if this is something you're interested in and actually learning more on the ELF side, you can look at like ELF files. So you can get information. It's the standard binary file format for executables. This Wikipedia page has some of this information, if not all of it. There's this really interesting walkthrough that they have here that kind of talks through some of this stuff. So you can see the headers, the sections, any of that stuff that's particularly interesting. So the ELF header, the program header table, all sorts of fun stuff here. But yeah, if you are interested, like you could probably take some of the stuff that we've written and follow along right here and see exactly where this is at. So for example, this one right here. So there's our offset for data. And then this byte is set to either 1 or 2 to signify 32 or 64-bit format, respectively. Right here, there's our 1 and 2. So yeah, if you are interested in this stuff and you're like, wow, this is really cool, but I don't understand any of this, you can like check out this table, follow along for these mappings. Essentially, these are all constants that we just need to reason with for our application. Same with our program header. We will unfortunately write quite a bit in this file. But yeah, let's get back to the Odin bits. Okay, so we have our core. We have our machine types. So if I do em none is 0, em x86. Let's go x86. 64 is going to be 62. I've already forgotten. It's fine. I've got my cheat sheet. Sorry. I was trying to remember these values suddenly, and I can just refer to my cheat sheet down here. Okay. Yeah, so this one will be 62. 64 will be 183. PT null. So these are going to, at this point, you know what? Let's add a comment. We're in our program headers at this point. So null, PT null will be 0. PT, if I can type, PT load will be 1. PT dynamic will be 2. Oh my God, please. Thank you. PT interp will be 3. PT note 4. PT p header is 6. Okay. We're almost done, or at least with the constants, and then we can get on to the cooler parts. So we have our program header flags as well for execute, read, and write, which we do need to capture because that seems like useful information. So if something is executable, it'll be a 1. If something is write, it'll be a 2. And if something is read-only, it will be a 4. Those numbers should look familiar for you Linux enthusiasts. Okay, let's add another comment because now we're getting into like the actual structure of these ELF files. So I've got ELF identification. right here. So what I want to do is we're going to set up a struct. And one of the reasons I picked this project is because Odin supports packed structs. And because it supports packed structs, we can get really tight structs for modeling ELF information. So hopefully if you were like, why is he doing this? Why is he doing ELF parsing? Hopefully this will start to make sense. So the way that the packed structs work are, I'm pretty sure it's just packed, right? It is packed. Yeah, so they've got some examples here about structs that can be tagged with different memory layout and alignment requirements. So if you specifically wanted to align a struct to 4 bytes, you could do something like this. If you wanted to remove the padding between fields, you can do it like this. And if you wanted to use raw unions, you could do that like this. The packed structs are really nice because they're going to make deserializing this data into our structs really, really easy. So we have a struct. We want it to be packed like so. And what we have is, if we go back to our Wikipedia page, which I'm not going to do, at least not right now, we have a magic string, essentially. And this is going to be 4 bytes. And if I remember correctly, I think it is something like OXF. No, it's not OXF. It's OX7F. And then E, it's capital if that matters, which it does. This. So we're able to get this, and this is essentially just going to validate that it is, a valid ELF file that we are working with. If we don't have our magic strings, then we aren't guaranteeing that this is an ELF file. In fact, it's not, since that is a requirement for ELF identification. So we have a class. Our class is going to be a U8. We have our data, which is also going to be a U8. We have our version. Guess what? It's a U8. And we have our ABI version, which is also a U8. And then we have our padding. And then we have our pad. And again, because we're working with packed structs, we get some nice tight requirements around the size of this. We're going to do the same thing down here for headers. So we have an ELF 64 E header, essentially EHDR. Again, this is going to be a struct, and it's going to be packed. And now we're going to take our ident, and that's going to be an ELF ident. So now we're combining structs. We have structs with structs inside of them. We have our type, which is going to be it's not a U8, it's a U16. We have our machine, which is going to be a U16. We have our version, which is going to be a U32. We have our entry, which is going to be a U64. And again, if you're curious about all the types, you can find this information wherever you would find documentation on the ELF structure. I just have a little notebook that I've jotted a bunch of this stuff down, and I'm trying to read my own handwriting, so bear with me. Okay, so we have our entry. We have PHOF, our program header offset, sorry, PHOF, which is U64. SHOF, which is going to be also U64. Flags, which is U32. EH size, which is U16. P size, which is U16. Program header num, which is U16. U16. Actually, the rest of these are all U16 as well. So we'll just go ahead and fill those out. SHS. TRNDX maybe? And then the last thing that we have would be our program header. So this would be an ELF64P header. It's also a struct. And it's also going to be packed. It's worth mentioning everything we're doing is assuming 64-bit. I'm on a 64-bit machine. If you are on a 32-bit machine and you want to explore 32-bit ELF files, you'll do something similar to this, but things will be a little different, and this program is intended to be ran against 64-bit files. One thing I'm curious about that I don't know if I've found any information on is if there is a convention for struct formatting. It is underscores. Okay. Well, Honestly, these are fine to not be underscores since they're very specific things, but we'll use underscores down here for the rest of them since maybe that's more appropriate. So we'll have a program type, and it's going to be a U32. We are going to have our flags, which is a U32. We're going to have our offset, which is a U64, big offset. Our V address, which is going to be a U64. Our P address, which is going to be a U64. File size, U64. P mem size, U64. And then P alignment, which is also going to be a U64. I think this should cover our structs. Just let me gloss through these really quick and make sure we're not missing anything. So what we've set up at this point is a bunch of constants so we can easily access them through the rest of our program, and then some structs to kind of handle the ELF specific formatting. Again, using pack structs to really lean into that and take advantage of the fact that Odin supports those. Okay, so what we're going to do now, I'm going to hop back out of Vim, just ls, so you can see where we're at. I'm also going to touch another file in ELF. This one's going to be parse.odin. ELF parse.odin. Since this is in the ELF package or the ELF folder, it's still going to be the ELF package, even though it's called parse. The package does not match the file name. I don't necessarily know if it has to match the folder too, but I think it will look for files and organize them into packages based off of the way that they're named, and then package them, bundle them like so. Don't quote me on that. I could be wrong, but that's good enough understanding to continue for now. So, you know what? Before we do this, though, let's just Odin build. Odin build dot. Okay, cool. I just wanted to make sure our Odin compiler was actually going to... oh, yeah, that's a bug. I should fix that. Let's fix that really quick, too, before I forget. Main.odin. There, problem solved. That should go away now if I build. Cool, it did. All right, yeah, so like read file, assignment count mismatch. This is all stuff because we don't do this stuff yet. This one's interesting because we do have our ELF module now, and it is recognizing that, but parse ELF header doesn't exist. So that's what we're going to build in our parse file, and we're going to just jump straight into that. So ELF parse.odin. I know I'm going to need some formatting, so I'm going to go ahead and import core format. We also have three things we want to do, right? So we want to parse ELF header. This is going to be a procedure. It's going to take in data, a slice of U8s, and it will return a bool as the second argument, because that's whether it succeeded or not. And then we need the ELF 64E header. Okay, this is what I was looking for. I think we need this caret, but off the top of my head, I don't remember exactly what this caret is. Is this indication of a pointer? Is that what this is? No tag is stored for pointers. Okay, so yes, this would be a pointer then in this case. Wow, I feel like that is covered elsewhere. I don't know why I'm looking in the demo file for that. In fact, this is probably a much better spot to look for it. Default values, the transmute operator, interesting. Yes, okay, address operator, perfect. For an operand of x of type t, the address operation ampersand x generates a pointer of $t to x. The operand must be addressable, meaning that either variable, pointer indirection, or slice/dynamic array, index, operator, or a field selector of an addressable struct operand, my apologies, or an array index operation of an addressable array, or, that's a lot of ors, a type assertion of an addressable union, or a compound. A lot of ors there, Bill. Okay. We'll come back to this, but I think what we need in this case is to indicate that we are returning a pointer. Okay, so this will be one of our functions. We know that we also have parse program headers. This will be a procedure. And it'll also take in data, which is a U8. And then it will need our headers, like our ELF headers. And then that will return a list of ELF 64 program headers and a bool indicating whether it succeeded or didn't. Okay, let's write one of these. I think we have one more, but we'll come back to that one in a minute when we need it. So if we're parsing our ELF file, first things first, we need our magic. So we're just going to go ahead and set up a const here. It's a 4. It's going to be a U8. We know the first one is 0x7f. And then we know the next one is E. The next one is L. The next one is F. That should cover it. So with that in mind, we can get into parsing the header. So if the length of our data is less than size of ELF 64 E header, then nil false. It is not okay. We don't have anything to return. This is an invalid state. Actually, let's go ahead and print line something too. The whole point of this tool is to be a diagnostic tool. It could be useful to surface diagnostics. File is too small to be an ELF. This is neat, right? Like this is something I kind of just glossed over really quick, but we're using the size of operator and we're passing a struct to determine the size. So we're looking at the length of the data and basically saying, hey, if this doesn't fit into this, it's not an ELF file because it needs to fill out at least the ELF headers. Okay, that's out of the way. We can use the cast operator here to cast to an ELF 64 E header. And what we want to cast, and this is so freaking cool, data. Bam. We have our header. That's it. Congratulations. We've parsed our header. How freaking cool is that? And again, this comes down to the fact that we have these packed structs that accurately represent how everything should fit into the struct. So we're able to just cast it like so. We'll go a little farther because we are trying to make sure that this is valid, so we can check things like the identifier magic is not equal to ELF magic. Fumped, print line, error, invalid, ELF magic. Sounds like I'm playing D&D. And then we'll return nil and false in this case. I'm actually just going to go ahead and yank this. I yanked too much. Let's try this again. Yank to this, paste, paste. Because we're going to check a couple more things, and they're almost all the same. So what we're going to do is now check the class of this. So identifier class. And if it is not equal to ELF class 64, it's not an ELF 64 binary. And then same thing here, but we want to check the Indianness of the identifier. So if we check the data on the identifier, and if it is not equal to ELF data to LSB, then we know that it is not little Indian ELF file. if these things pass, we can return our header and return true. That's it. We've got our ELF file. We're going to do something really similar to the program headers as well while we're in here. Before I do, though, I just want to point out, like, the parsing. I'm going to make this sound a little too simple here, but the parsing is this, right? It is this because we set up a pack struct and, like, we have some magic that we're able to do here with our cast operator because things align perfectly. But that's essentially the check, right? We're trying to make sure that it matches and casts properly. And, if everything's good, then we're good. I just think that's really nice. Okay, parsing our program headers. You just saw more or less what this looks like. So we're going to do, it'll be a little different here. But we essentially want to get our table size, which is going to be a U64 header.phint size, no underscores, times U64 header phnum. So our program header size and then our program header number. If header.phof plus table size is greater than U64 length data, then we have an issue because our program header table goes out of bounds. So this will be format println error program header table out of bounds. Also, slight tangent here, just from a first impressions perspective. There's some parts that clearly are not Go. Like, well, honestly, if you look up on line 31 or 4 lines from where we're at currently, since I've got relative numbers on, that doesn't look like Go at all. But if you look at everything inside of this function, it looks like Go. Or this procedure, my apologies. This looks like Go. One thing I'll just add, I know Go. I've been writing Go professionally for 6 or 7 years now. Because I know Go, I feel like I can just kind of fly through some stuff in Odin, which is really, really nice. And there's definitely stuff I'll stumble on that isn't exactly correct, or not correct, but isn't exactly mapped one-to-one from Go. Or maybe it is mapped, but it's just mapped in a way that isn't maybe necessarily intuitive. But all this to say, if you know Go, Odin could be pretty easy to pick up. I'm kind of just breezing through it because it all feels very familiar to me. And worth mentioning, we haven't actually compiled anything yet. So successfully compiled anything yet. So I'm saying this, and I don't have an LSP to help me out or anything. I've probably made plenty of typos, but we'll deal with that as the time comes. But in the meantime, I feel like I'm just breezing through it, which feels great. So, okay. So we are checking our header. This looks good. Making sure that the header table is not out of bounds. Then we can do p headers. And again, wow, this is going to look like Go. ELF 64 p header. And then header, program header number. So the number of headers. Nice little make, just like Go. For loops. Show me loops. I know that the syntax is... Okay. Range loop. I think that's what I want. There's ranges, right? Like range. Oh, wait. Yeah, this is exactly what I want. Perfect. Okay. Oh. Interesting. Yeah, this is fine. Okay, so for I in 0 ... Yeah, let's do that. Range program header num. Perfect. We're going to get our offset, which is going to be our header program header off plus I don't know why I tabbed back over. Yeah, U64. We need to convert both of those to U64. Program header and size. Let's try that. Does that make sense? Program header offset plus U64 index. Yeah, that makes sense to me. Okay, we have our program headers. index I. We're going to use that cast operator again. So we're going to cast to an ELF 64 p header. And this part's going to look a little weird, but we're essentially going to take that data. Oops. Oh, Lord, wrong thing. Data will actually be out here. And we have our offset here. And there we go. Okay, so we are casting to a pointer of our ELF64 program header. And the value that we're casting is this data sliced by the offset with a reference. And then the caret here at the end, I believe, is a dereference, if I have that correct. Oh, this is interesting. Sorry, the transmute operator is a bit cast conversion between two types of the same size. Is this new? Should I be doing this instead? Yeah, this is interesting. This is what we're trying to do essentially. Interesting. We'll stick with this for now, but it's interesting to know that this transmute operator is available too. But yeah, essentially it's a bit cast conversion. Interesting. I did not realize this existed. I looked through the docs previously just to kind of get an idea of what I was going to be able to build with this, but I did not. I don't know how I didn't notice this, but anyways, that's fine. We'll move on for now. If we make it to this point, we can just return our program headers and then true because everything turned out okay. Okay, so we have our program headers. We have our ELF header. What was the other thing that we were doing in here? I know we have ELF, parse header, print header, parse program headers, print program headers. We'll do the prints in a minute. Find interpreter. That's what we're missing. Take me to parse. So we're going to create find interpreter. This is going to be another procedure. This is going to take in data. It's going to be a list of U8 p headers, list, slice, array. I don't know specifically what the appropriate term for these are. I probably should check that out and make sure that I'm saying the correct thing. But in our case, they're representing the same concept. It's just whether there are constraints on them that I may not be properly articulating. Okay, so find interpreter, it's a procedure. It takes in data. It takes in our program headers, and it returns a string and a Boolean. Okay, so I essentially want to iterate through each of the program headers. So for program header in p headers, if p header.ptype is equal to pt, do we call it pt interp? ELF, what you got? pt interp. Yep, okay, cool. pt interp. Then the end is going to be program header offset plus program header p file size. If end is greater than U64 length data, so let's just go ahead and coerce that. Then we run into essentially another out of bounds. I don't really know how realistic this one would be that we would run into this, but this would be, yeah, another out of bounds check. So that's fine. We can just return an out of bounds there. Okay. If we don't run into that bounds check, we can get the interp bytes by slicing into data, program header, p offset, and then we want to slice until the end -1. And then we can return, coercing this to a string, interp bytes, and true. If we don't end up finding anything by the time we iterate through our headers, we still need to match our return type. So we'll just return an empty string, false. Okay, that's a lot. I'm just going to give this another build and we'll see what we're missing. There's a lot of expecteds here in parse. I just want to make sure elf parse. Just want to make sure I didn't goof up somewhere.
2 hours later.
I'm not seeing anything that looks particularly off, but it might be helpful to actually take a look at one of these expected lines. So it looks like, honestly, it looks like every line has some issue. So 15, 16, 17. Okay, yeah, let's just take a look. Take me to 15. I don't know. Kind of interesting. I think maybe what we do for now is we continue and we can revisit this if we're still having issues once we build out some of the rest of this. Okay, let's go ahead and build out our print file. So print Odin. Package ELF. This one I should be able to move a little faster through, which is good. This is already, I'm not sure if it'll be this way after I get to editing, especially after editing out all my coughs, but we're at the 1 hour mark. So I will move a little bit faster for this just to make sure we're making good use of your time and my time. But essentially we're going to print a header. So we're going to take in an ELF 64 E header, which is our ELF header, just if that's not clear. So format print line ELF header. We'll do a print here since we're going to get into some specifics. So let's just do 4 spaces. And then here we can switch the identifier class. So we have a switch keyword that we can use here. And we're going to just use cases from those constants. So if we have an ELF class 64, we can do format print line ELF 64. You get the idea. Case ELF class 32, fumped print line ELF 32. And then we have essentially a default case, which I believe is just the case keyword. So case print line unknown. Wish the formatter would be a little kinder to me here. Also, I mentioned this previously, but just with like tooling, I don't think Odin ships with a formatter, which, you know, whatever. It's fine, I guess. I would prefer if it did, but I'm also, I think I've accepted the fact that I'm probably not Odin's target audience as well. Indianness. Let's try that. 2, 3, 4. 4 spaces. Same thing. You know what? Actually, almost all of these are going to follow the same pattern. I'm just going to burn through this really quick, and then I'll edit it down so that it just has, well, I'll just cut out the part of me typing out all of this. We'll walk through the code. There's not anything crazy going on here. We're printing values in a struct. This is stuff that you are probably more than comfortable with doing, and it's not particularly Odin interesting outside of what you've seen right here. So yeah, bear with me. I'll be back in just a second. Okay, I'm back, and I lied. There actually is a pretty interesting part to this, so we're going to talk through it as well. Everything you're seeing so far is more just case switches, and it's not particularly interesting. Print F, so just, you know, printing with a format. I don't know if that's actually necessarily that particularly interesting, but we can get into some others as well here. So like this %x modifier that we've got going on. I just think it's important to call out like string formatting. I know that most modern languages ship with really nice like string format, like Zig's a great example. Go's is pretty good. But also coming from some languages that don't have like rich formatting of strings, yeah, always nice to see it. So I was writing this part down here, and I just realized that, you know, this formatting is actually something we probably should talk about. So yeah, that's it though. This is really just printing those structs. So there's not a ton going on here. I've not changed anything outside of this file, but let's give it a write, and then, oh, old habits die hard. Odin build. Okay, still getting yelled at. Parse.odin expected an operand. I just don't know what I'm doing wrong. I specifically mentioned that I don't know what I'm doing wrong because I think we're at the point where elf/parse, where this should start coming together at this point. So expected an operand on 15. Is this not an operand? Have we suddenly decided that not equals is not an operand? Oh wait, not equals is not an operand.
2 hours later.
Ah, dang you ligatures. Okay, my not equals is incorrect. Sorry. I gotta make sure we're not doing that anywhere else. I think we're okay. Yeah, worth mentioning, I've got ligatures turned on. I had a triple equals. It just keeps going, doesn't it? I had a triple equals. I had this and I needed this. Man, yeah. Amateur mistake. You know what? I said that, but I haven't even checked. Okay, yeah. We do get much further along, which is great. So, oh, in print, we have OSABI. Okay, we have an issue in print. Let me just double check that one on 29. Oh, did we miss something in our ELF file? Oh, we did. That would have been bad. So especially with this being a pack struck, we would have been missing out on the OSABI, which should be a U8. Wow. Yeah, that actually saved me. That would have been a really painful thing to debug later and would have caused all sorts of issues. That worked out great. Okay, so in our main.odin, we have an assignment count mismatch. 2 is not equal to 1. That totally makes sense. And an undeclared name read file. It's because we haven't written those yet. So I'm just going to create one more file here called io.odin. And what I'm going to do is io.odin. We're going to put this in our main package. We're going to import core OS for file reading. We're going to import core fumpt for formatting. And I'm just going to create that read file procedure. I just wanted to pull this out so it can be kind of isolated and we don't have to do all the file reading management type stuff in our main. And we can just do that here. So it's going to return a list of U8s and Boolean indicating whether it was successful or not. Again, this actually, out of all the things that we've written, this is probably going to look the most like Go, which is pretty cool, especially if you're a Go dev. So we've got our file. We've got an error case. We're going to call os.open path os. I want to open read only and then a 0 there. No semicolons. Man, I got this. I've been doing a good job not writing semicolons, but that one snuck in. So if you're curious more about this, we could take a look at this. So like OS, and you can see the open. Oh, I just had it right here. So you can see the procedure right here, path, mode, permissions. I think these are defaults. So actually, where did it go? Okay. So right here, we actually probably could just do the path since, why do I keep clicking that? And it takes me to, I guess it's nice that it takes me to string, but I need to stop clicking. Since read only is the default and then the permission set is 0 by default. So yeah, let's do that too. Shorten this up and make it even nicer to read. That being said, it is kind of nice to explicitly set those so people reading this code know exactly what the permission set looks like, but it's fine. Errors. I wish I had some autocomplete here. This is the one I want, I think. Error none. Yeah. So if error none, print line, failed to open file. And then we just want the file, so path. If this happens, we can return nil and false. False for not okay. And the part that is really cool about this is we haven't talked about this yet, but there's a defer keyword. So we can defer closing the file here as well, which works out great. That's part of the reason I wanted to pull this to its own procedure, is because I don't actually care about the file. I just want to load it into memory. And if I have this all handled in one procedure where we open the file, load it into memory, and then close it, and then give the contents of that file that have been loaded into memory back to my main procedure, that feels nice. That feels like good, proper encapsulation. So let's do some stuff here. We'll call this stat error. That might be a better name because we're going to call OS stat and stat the path to make sure that it does exist and we can stat it properly. So if there is a stat error, actually we check if it exists in the previous error set, but now we want to make sure that we can get the stats for the file. So again, let's do print line, failed to stat file, something like that. Okay, cool. Let's make a buffer, right? So let's make a buffer for a list of U8, and it'll be based off of the size that we get from statting it. So we can go ahead and pre-make that buffer size. And then we want to capture the bytes that we read, or the bytes that have been read, I guess. And then our read error, if there is one, from OS read. We had this up moments ago, didn't we? Read, show me read. The handle and the data. Simple enough. So the handle is our file, and then where we want to store the data is that buffer. If read error is not equal to OS error none, or if we convert our bytes read to an I64 and it's not equal to info size, then we failed to read the file. So let's just format print line and say failed to read the file. We can return nil and false in this case. And then if we finally make it to the bottom, we've loaded everything into our buff, and I need the return keyword there, but we can return buff and true. Okay. No way. Okay, cool. We did sort out most of our errors earlier, I guess. It felt pretty good seeing that actually come together. I have like a rough outline of, I've got all the ELF stuff written literally right over here. And I've got a rough outline of like pseudocode for what I'm wanting for this program. But still just kind of shocked that I was able to get a successful build. That being said, we basically had a successful build right here. And all I added was like 30 lines of file reading. So whatever, not that big of a deal. Okay, so yeah, so our Odin build succeeds. We can do Odin run. I lied. So if I just type Odin run. Oh, I need Odin run dot. Okay. Yeah, cool. That makes sense. So if I do this and then type in like ls, oh, that actually, that makes sense. Stat? Yeah, okay, cool. Let's try stat. You know what? That makes sense. User bin stat. Okay, cool. Hey, that's much better. Man, okay, that's actually pretty sick. So we have our ELF header. We have our class. So ELF64, our Indianness. So we can see that it is a little Indian. Our ABI, we can see that it's system V. Our type is dynamic. Nice little pie. Our machine this is compiled for is x86, 64, and then you can see our entry point here. We have our program headers, including our interpreter, our load, some dynamic headers as well. You can see that that's all right here. The interpreter is lib64 ld linux x86 64 so2. That feels pretty good. What other programs can we run into this just to make sure that this isn't like stale data that shows up on everything? What else do we have in the bin? Okay, too much. What do we have if we bzip2? And then for comparison, here's stat. So, okay. I'm expecting some of these to be the same, like specifically the ELF headers up here. So you can see that they are basically the same. The entry point is a little different. And actually, that's really the only difference between the ELF, but the program headers are different, right? So you can see that we're loading. Yeah, this is a better way to look at it. So you can see like the addresses are actually, they're different here as well. So there's a different address. Well, it's the same one as this one, but the one underneath it is different than this one. So you can see that we're working with different address spaces, different file sizes, different memory sizes, all sorts of different stuff. So yeah, cool. This makes me feel like this is working pretty well. We can run this into other stuff as well. I'm just curious, do I have a Dust binary that we could run this on? So if I go up to Dust server, zig out, bin, Dust server, boom. We do. I've got a little zig binary that we can look at as well. So you can see, again, almost all the same. This is actually interesting. So the previous two types were dynamic. This one is executable. So the type there is exec, and then the entry point is vastly different. And then the program headers are also quite a bit different. Anyways, I don't guarantee the correctness of the ELF bits of this at all, but hopefully this has been a fun little journey in exploring ELF and Odin together while talking about some of the things that make Odin cool, but I couldn't find a way to make a program where all of the things about Odin that are cool made it into one demo / first impressions video from me. So if you have particular parts about Odin that you think are particularly darn awesome and would love to see more, I would love it if you would let me know in the comments below, because I actually was, much to the chagrin of the people who have been telling me to check out Odin for months now, I actually am pleasantly surprised. This is a neat little language. I don't like this syntax. Double colon, I don't like. Just call these functions. I know that they're not functions, they're procedures, and there's a difference, and if you want to be pedantic, we can split hairs all day on it. But yeah, there's like a couple syntax gripes that I have that are like the lowest of low in terms of things that anyone should actually care about. But a lot of things I will agree with the syntax is that it's really simple, like Go. It feels like Go, but lower level, which is really nice as well. I'd actually, you know what? I would love to use this language for embedded systems. This seems like a really nice ESP32 or Raspberry Pi, Arduino, BeagleBone, that type of stuff. Seems like a really great language to program microcontrollers. I don't know if that's possible. I don't know if the tooling is set up for this. I'm sure it's possible, but I don't know what the community around that looks like. But if you know, also let me know in the comments below, because this seems like a good use case for Odin for me. It would be microcontrollers and things of that nature. So if you know of any tutorials or anything to get started, I would love it if you shared those. I'm rambling. This has gone on for quite a bit. Thank you so much for your time. I really enjoyed doing these first impressions videos, but I don't know if I would do them if I didn't have people who actually cared to watch. And I know it's a big time investment on your part, but it means a lot to me that you stuck through this. And thank you so much for your support with this video and honestly, everything. If you haven't yet, subscribe to the channel, hit the bell so you get notifications. You don't miss out on other first impressions videos. There might be more of these coming soon. And you'll also get other updates for anything else that I'm working on, which is mostly Zig and Gleam at the moment, but things may change. Besides that, if you found the video helpful, give it a thumbs up. It helps me. It helps the algorithm. I'd like to think that helps you hopefully get good content and not just rage bait from other popular tech YouTubers. And maybe you'll be able to learn something instead of just get angry. I've got some thoughts on that, but I'll save that for another time. And then finally, if you haven't yet, don't forget you can join us in the Code with Cypher Discord, where people talk about all sorts of stuff. We've been talking a lot about Gleam. We've been talking a lot about Zig. We've been talking a lot about Steam Decks and some old Sonic the Hedgehog games as well. So quite the cast of characters there, and I would love it if you joined us. Yeah, I think that's it. So thank you very much, and have a fantastic day.